Unfortunately, I haven't been here the rest of the day. I haven't heard what others have told you. I have noticed, though, at security conferences, typically the presentations follow a certain pattern. And so I'm gonna just sort of gamble that previous presentations followed this pattern. The pattern is usually that the speaker tells you a whole bunch of really scary things about why you should all be really nervous, and then they tell you something that should make you feel a little bit better about it. So I figure you've probably been hearing a lot of scary stuff today about how, how much risk there is out there and how many bad things are going on. My first thought was maybe I wouldn't have to address all of those things, but then a different part of my brain kicked in and I thought, let me just see if I can think of some things nobody else has thought of telling everybody about that they should be scared of. So that's what that's where I'm gonna start. Quick glance at where we are now, and by now I mean like a couple of years from now, and what its implications are. And then I'm going to show that those implications actually give us something to work with, that there's some good news there as well. So first place I want to start, we've all realized for years that perimeter security is not a great approach anymore. This is old. We need to do something besides perimeter security. I think it's really good that we've had that realization for a while, because now what we can see is that the perimeter is disappearing entirely. It's hard to say there's a perimeter anywhere anymore when we are working in a bunch of different cloud providers. We're using a bunch of different SaaS providers. And there's almost nothing that you could say is the thing that is ours. What replaced perimeter security, I think, we all started to talk about endpoint security. Don't stop me if this sounds familiar. I'm just going to keep blasting through. It turns out that our endpoints actually are going away as well. I don't know if there's been talk about this, but what's going on now in the cloud is this serverless computing model. For example, Amazon's Lambda service. Essentially, what we're doing is we're providing code and saying under what conditions it should be executed, and Amazon is somehow applying compute resources to it. And that's all we know. We don't know anything about any servers or endpoints that we have to deal with. It's maybe the one thing that we can still grab onto then is that there are networks and we've got to protect networks. But really what's going on that front is software-defined networking and networks that can reconfigure themselves dynamically. And in a world that we're coming from where we can take an application network and test it, do our security testing on it, I'm not sure we even have a metaphor for what comes next here. I mean, we don't actually have a network, or we have a network that's going to reconfigure itself all the time. We don't have any endpoints to work with, and by the way, applications, they don't really exist anymore. We can't really secure applications because everything's going the way of microservices. So really what we have is a whole bunch of endpoints, each of which is a microservice, and they group together in different ways to support different capabilities. And so where exactly is the application that we're going to test and secure and so on? So I think the world that we're on the cusp of here is one that is much more fluid in a lot of ways and much more dynamic and constantly changing. And the point that I'm trying to make really is that our security models, I believe, are very backward looking at this point. It's especially hard to change on a big scale with as well-developed a security program as the government has, that was created in a world where we had data centers and we had things behind a firewall and so on. What we really need to do, I think, is dramatically rethink what we mean by security and what our security model is, given all of these givens, that we don't really have networks, we don't really have applications, we don't really have endpoints. It's a very different environment that we're looking at. It happens that as all of these changes have been playing out, there are changes that have been playing out in how we deliver IT systems that maybe help with these things, that help us work with applications and systems that are more dynamic, networks that are more dynamic. And I think the interesting place where a lot of these developments have been happening is in the software delivery approach called DevOps, or its related set of practices called continuous delivery. So continuous delivery, let's define it a little bit. What it means to me is that we use an automated process to very frequently deliver software into production in tiny, tiny pieces. So what we're trying to do with a continuous delivery system is deploy very, very frequently, but each time we deploy a tiny little thing. Those two go together, really, right? When the government was deploying its systems every 18 months or 2 years or whatever we were doing, each of those deployments was a big thing. It was a big, risky thing because we'd been saving up 2 years' worth of changes, and who knows what's going to go wrong when you start putting those changes out there. Instead, the continuous delivery approach says, we're gonna change the risk model. What we're gonna do is we're gonna deploy extremely often. We're gonna deploy tiny little things that are unlikely to cause disruption in production. And we are going to set up our process such that we can do these deployments very quickly. There are a lot of techniques that we bring to bear to make those things possible. For example, we do automated builds, automated tests, automated infrastructure provisioning, automated deployments. I guess that would be the big four right there. Because this pipeline to production is extremely automated and extremely reliable because we use it over and over and over again, we know that we can take a new change to the code and put it into production in no time and do it in a reliable way. The more often that we do it, the more confidence we have in our system. And any problems that we might have are going to show up very quickly with a system like that. So old world, you do your deployments once every however many years. When it's time to do that deployment, you're really scared. You haven't done a deployment in a long time. You don't know what's going to happen. It's a big deployment. All sorts of things can go wrong. The DevOps model, continuous delivery model, is to get into the opposite position where you're deploying so frequently that it's just normal. It's just something you do all the time. It works every time, so what is there to worry about? That's true to the extent even that in companies that are using continuous delivery, employees often on their very first day of work are asked to deploy something to production. That's how simple and reliable it is. The tests are automated. We're in good shape. So this approach to delivering software has caused a lot of rethinking on technical practices, and a lot of practices have been developed that support that I think have very big implications for how we think about security and how we respond to those changing conditions that I mentioned before. So let me talk through a few of the ideas that have come in with DevOps and continuous delivery. I should actually define DevOps for a second here. I talked about continuous delivery, this rapid deployment of tiny pieces of functionality. DevOps is more of an organizational practice that brings together development and operations using a continuous delivery process where a single team can be responsible for both development, testing, and operation of the system in production. So a single team has full stack expertise, can manage the entire pipeline, and can own a piece of a system throughout that entire life cycle. So that's what I mean by DevOps. It's a related practice to continuous delivery. So one of the concepts that's come in with continuous delivery is, actually, one more little digression. I said very frequent small deployments. I'm not sure if you're aware of the state of the art. When I say frequent, I mean up to hundreds of times a day or thousands of times a day, deploying tiny pieces of code. Amazon is famous for announcing at one point that they were deploying every 11 seconds. At our agency, some of our systems are deploying once a week. Some of them are deploying once a day. And I'm looking to make that much more frequent. I'm looking for multiple deployments a day across all of our systems. So that's the scale of things I'm talking about. So the first concept that I want to introduce is a lot of continuous delivery people talk about their infrastructure as cattle, not pets, if you've heard that expression. The idea is in our old world, we create a server. There's a sysadmin who creates the server. They set it up, then they tweak it, and then they play around with it, and they fat finger a few mistakes and whatever. And every server is different. You don't really know what you have. The servers become pets. You might as well give them a name. And you're afraid to lose that pet because how are you ever going to create another server that looks just like that? The DevOps concept is treat your servers like cattle, where you can't really tell the difference between one and another. Since we do our deployments in an automated way, and we do our server provisioning in an automated way, we can make sure every server looks exactly the same as every other server if we want to. And more importantly, really, you don't, when you have a pet, you don't really want to see it get killed. But cattle, you just, they're going to go to the slaughterhouse eventually. So if our servers are cattle, we can kill off servers. What's the difference? We just stand another one up. And with the cloud, that's entirely possible. In fact, we do it very deliberately. We kill off servers, and we set up our system so that when a server dies, it stands itself up again automatically. And we can do that because everything is automated for creating a new server. It can be done very quickly, and there's no work of art involved in the server. It's a cow, So one of my favorite concepts is this idea that Netflix introduced called a chaos monkey. A chaos monkey is a Netflix script that runs in production. A lot of other companies use it now too. And it randomly kills off virtual machines in production. Just randomly kills them. And I'm happy to announce that we use this at USCIS. We have our chaos monkey, and it randomly kills things in production. If it's working, then nobody notices the difference. Because as soon as a server dies, the system realizes that the server is dead and loads up a brand new instance and adds it to the cluster, and everything looks normal again. So the chaos monkey is a way of testing that your system actually is resilient, testing in production because that's the only place where it matters. And just like I said, deploying very frequently, you stop being nervous about it because you've done it so many times before. When the chaos monkey is killing off your VMs randomly and nothing bad is happening, you feel confident that your system is resilient, right? What are you going to worry about? So we have this concept of servers as cattle, not pets. We also have the concept of nobody needs to touch production. So if we're doing this correctly, everything is done by script. And so deploying something to production means you press a button and the script runs and puts things in production. So your sysadmins, nobody else needs to fool around with production machines. You don't have any danger of fat fingering, but obviously you don't have the danger of somebody mucking around with your production servers. The scripts are in version control, they're auditable. You can have whatever approval process you want for your scripts, and you can make sure that when the deployments are done, they're done the way that they are supposed to be done, according to your model. When a virtual machine has been deployed and it's been configured and stood up, if something needs to change in that, this is the concept we call immutable infrastructure, nobody can change it. There's no need to, because in order to make the change, you just deploy a brand new virtual machine with the changes, wipe out the old one, and use the new one in its place. So this is really powerful because now we can enforce the idea that our infrastructure is not allowed to change once it's in production. So if a bad guy happened to get on one of our VMs and make some changes, we can set up the system to automatically detect that and set it back to the way it was before. The infrastructure is immutable. If we need to patch something, that's what we do. We just make a brand new instance of it and throw it out there. All of this put together leads to this way of thinking where you expect your production servers to die frequently. Anytime you want to make a change, you kill it, make a new one. Anytime you want to change the system, anytime you need to patch, get rid of it. It's disposable. So while you might see this fluidity as a challenge for security, the flip side is that we can respond in this fluid, very quick response sort of way. We can deploy any changes we need to patch up vulnerabilities. We can do it in no time. We could do it with very little impact to users in production. We can detect when things have been changed that shouldn't and immediately replace the system. So what we maybe sacrifice in having to use a very fast process to get things to production, we gain in having control over the fluidity of how we can respond and how we can deploy things that are cattle rather than pets, and how we can be resilient and stand things right back up again when they come down. So I think those were the main. Actually, let me introduce one or two other things that pertain to resilience. Typical architectural approach that's used with continuous delivery is breaking applications into microservices. So instead of having one big application, I mentioned this before as perhaps a challenge that we don't have applications anymore. When we break things into microservices, we wind up with small units of capability that we can make independently high availability. So instead of trying to make our entire system high availability, we can take each microservice and make it independently high availability and have the microservices talking to each other. So what's typical now is we take our service, we put it into a container like Docker or use Cloud Foundry or some other container framework, and then deploy it to a bunch of VMs with clustering between them. And so that service is not going to go down because we've set it up for high availability, nor are the other services going to go down. And when it's time to make a change to it, we could do it in a high availability way where we're deploying, let's say, to a few of the instances in the cluster, and then as we see that everything's working fine, deploying it to more and more of the instances until it's completely taken over without any downtime for the users. So the general approach gives us this high availability, high resilience environment where the environment is immutable once we put it out, and it's hard for bad guys to get that foothold, I think, and be persistent since we're regularly killing things off. So all of this is not fantasy. At U.S. Citizenship and Immigration Services, we have actually switched entirely to a continuous delivery DevOps process for all of our systems. We're in the process of re-architecting into microservices with these container patterns. We have automated pipelines to production that include not only automated functional tests, unit tests, and so on, but we also do static code analysis for security purposes. We do code quality metrics through static code analysis. We do Section 508 compliance testing through automated tests. So we can take the tests that are specific to our system and add anything else we want for compliance and make a robust testing suite and run that testing suite every time the system is built, or for the tests that take longer to run them, let's say, on a nightly basis, and start with a hardened system and regression test it constantly using these suites of tests to make sure that it remains hardened and that we can deploy it at any instant. And that's how we get to those really fast deployments. So as I said, we're deploying once a day, typically, on our very big systems, a little bit less frequently than that. And we're setting ourselves up to be able to respond to emerging threats, emerging vulnerabilities, things that we discover with this tiny, tiny time to repair, which at the same time, because it's just part of our normal everyday way of doing things, we could do with high confidence, and we can do in a way that gets value to users very quickly by introducing new functionality. So that is the DevOps model and continuous delivery and how it impacts our resilience. And I think if you put the pieces together between that and the emerging challenges that I mentioned at the beginning, you can see that it's of like kind. You know, the kind of challenges that we face are addressed by the kind of deployment system that I'm talking about here. So that's why I don't think you should be scared by the things that I started out with. I don't know what else has been said today, but I hope that this addresses a lot of those fears as well, or at least as a path forward. So thank you. Is there time for questions? Or?
Probably one question. Just one question. Thank you. These are somewhat new concepts to me, so I may or may not have understood or taken everything in. Given that the production server farm, if we can call it that, given this particular style or design, the weakness then at that point of time is the developers themselves and the systems on which they're writing the initial code. How do you create micro segments of those as well, or are they still using traditional laptops to write that code? And then how do you do the security for those?
Yeah. So the idea is to constantly be testing at all levels, right? We try to push all of our testing to the left, so to speak. So instead of doing a lot of development and integration and then testing, we give the developers the power to run the tests themselves, the same tests that will be downstream. This is even more extreme when you're using the extreme programming technique of test-driven development, where you write your tests first, and then as you're developing your code, you just keep rerunning those tests. So all of the environments are secured using the same pattern, basically. We are running the same security tests. We're using the same deployment scripts to deploy onto their laptops, onto the VMs in the cloud that they're working in, into our development environments, our test environments. It's all managed by the same script. And that gives us a chance to start using those scripts and testing very early in the development process, and then just make sure no regressions appear later. That's it? All right. Thank you, everyone.